Hey guys, so today we're going to do 5.3, and I'm actually really excited about this lesson for the fact that it's going to help you out with justifying your answers on the AP test. A lot of times in FRQs, you're just not doing the math. You're justifying why your answer is what it is. And that's where a lot of students lose points. So I'm glad this lesson is in our planning, our book, anything like that. Okay, so let me read this to you, and then we're going to go through not only how to find the answers, but then how to write it to justify. An extremely common type of free response question in the AP Calculus test is one where a graph of the first derivative, remember we talked about this in 5.2, is given, and students are asked to make conclusions about the original function with justification. Typically, these justifications require a short sentence. It is unnecessary and unwise to write more than one sentence for justification. If a student justifies correctly, but continues to write a false statement, the justification point is now lost. Okay, so we're going to learn how to condense what we're saying correctly to keep that point, okay? Many students find it helpful to draw first or second derivative lines or sign charts, right? These number lines do not count as justification. They're your side work that they don't look at, okay? It helps you answer the question correctly, but it does not do the justification, okay? So let's look at our example here. The graph below is a graph of f prime, so the first derivative, of the function f of x. The graph of f prime has a horizontal tangent line at x equals 2 and x equals -2. So right here, what I might indicate on my graph is to remind me that these are horizontal tangent lines, which of course means the slope is 0. It also says the domain is -infinity to infinity, which means these go on, okay? So let's look at question number 1. On what open intervals, so open means no matter what, we're going to have parentheses, right? Is it increasing? Well, first of all, let's do some side work here. Let's do our sine ray. F prime of x shows me that my critical numbers are where f prime equals 0. So we have a critical number at -4, at 0, and at 4. Now let's see where it's positive and negative. So less than -4 is a negative. Between 4 and 0, positive. Between 0 and 4 is negative. And after 4 is positive. Okay, what do we know about this number graph? Okay, the sine ray. Well, where the f prime is negative, that means that f of x is decreasing, increasing, decreasing, increasing. All right, let's go on from there. So let's answer this question. On what open intervals is f increasing? Well, I go back to my sine ray, and I can say that it's increasing from -4 to 0 and 4 to infinity. Now, this is my answer, but I need justification. How do I know it's increasing? Well, I know that f of x is increasing because f prime is greater than 0. Now we can say greater than 0, you can say is positive, things like that, but that's as short as it needs to be. Let's go on to the next. On what intervals, now this is no longer open, right? So we're going to use our brackets unless it's an infinity sign, is f decreasing? All right, well, we have negative infinity to -4 and 0 to 4. How do we know this? F of x is decreasing because f prime of x is less than or equal to 0. Now, I knew it was equal to because we're using brackets here. Okay, guys? Now, I want to note, though, that if you didn't remember the brackets, it is okay. You would still get credit for this, okay? So if you put parentheses instead, just have not equal here, and you should be able to get credit. They're not going to be that picky on that one, okay? All right. At which values is there a relative maximum? Well, let's go back up to our sign ray. Right here we have it, a min, a max, and a min. So at what x values does f have a relative minimum? Well, it has a minimum at x equals 0. Okay, that's our answer, but what's our justification? Because f prime, how do we know? Because the f prime of x didn't change, right? It went increasing to decreasing. But technically, what went increasing to decreasing? F of x. We need to talk about f prime. So how do we know that there is a maximum? Well, it's because f prime went from positive to negative. So make sure that when we use f prime, you're talking about positive, negative. When you're talking about concave up, concave down, that's where we're going to talk about increasing, decreasing of f prime, okay? So again, we'll get used to this, but this is a good justification. Next, at which values does it have a local min? So you guys can look, mine's up here. So we have a min at x equals -4 and 4. Now, it says x values, so all you need is the x values. And technically, we can't find the y values in this case because we don't know the function to plug back in. Be careful if it says x values or points. How do we know this? Because f prime, and of course, we look at it as f going from decreasing to increasing, but we're talking about f prime because that's what's given to us. So it's from negative to positive. I should say changes, or it goes from changes from negative to positive. Okay, next. On what intervals is f of f concave down? So when we look at concavity, we actually have to look at f double prime. We've been talking about this for the last few days now, that we got to remember that f double prime is the first derivative of f prime. So when we think of first derivative, we got to figure out where the slope is 0. We see in our graph that the slope is 0 at -2 and 2. And when we talk about the first derivative, we talk about increasing, decreasing. And as you can see, less than -2 is increasing. between -2 and 2 is decreasing, and then after 2 is increasing. So what does that mean about f of x? It means it's concave up, concave down, concave up. So when we go back here, we say on what intervals is it concave down? Well, we're on the interval from -2 to 2. Okay. Now, here's a better explanation of justification. When you justify, you have to use what's given to you. What's given to us is f prime. Okay. So when we say because, we have to talk about f prime. So how did we know that f of x was concave down? Well, it's because our f prime of x was decreasing. At which values does f have a point of inflection? Well, we have to say at x equals, we have a change at -2 and 2. And how do we say this? Well, there's 2 ways we can say this, okay? First, we can say, referring back to f prime, because f prime changes. Now, we're not going to say changes from this to this, because that means it's only one way and not the other, but we're changes between. And remember what we talked about up here? We talked about increasing, decreasing, between increasing and decreasing. Now, the other way we could say this, still using f prime of x, we could say that we know the concavity based on that f prime has local extrema. Remember the second derivative test? I think most of you are going to remember this first explanation. Okay. All right, last question, guys. On what intervals is f both decreasing and concave up? Justify your answer. I'm going to bring these 2 sine waves down so we can actually look at what's going on here and we can evaluate them. Negative, -4, plus 0, -4, positive. And then right underneath, but I'm going to do this in the area. -2 comes between -4 and 0. So see how I did that? Label that. This is not your justification, though. Remember that. 2 comes before there. Okay, and then of course I put this here. All right, so if I were to use something, right? So where is it both decreasing and concave up? So remember, this is concave up and decreasing is right here. Concave up and decreasing. This is decreasing, this is concave up. So right here, do you guys see where I'm highlighting this? So right now I can give you the answer, which is from -infinity. And look, it stops at -4. And it starts at 2 and goes to 4. Now, how do we know this? And we have to do it based on f of x, or f prime. Because f prime, and how did we know that? F prime was negative, and this is concave up, but what did concave up mean for f prime? It means that it's increasing. So f prime is negative, and like I said, this is concave up, but how do we know it was concave up? We know it's concave up because f prime is increasing. All right, guys, there you go for some practice.